Section 5.5 is integration by substitution. So what this kind of reminds me of is back to our derivative rules, where we were doing derivatives using U substitution. What this really was the chain rule, right? So in the chain rule, you looked at it as a composition of functions. You found the derivative of the outside, kept the inside the same, and then multiplied it times the derivative of the outside. And that's what this is saying right here. It says in this section, you will study techniques integrating composite functions. The discussion is split into two parts: pattern recognition and change of variables. Both techniques involve U substitution. With pattern recognition, you perform the substitution mentally, and with the change of variables, you write the substitution steps. The role of this substitution in integration is comparable to the role of chain rule in differentiation. So recall that rule for differentiation. This is where we had the compositions of the two functions. So you had f of u and u is g of x. So in other words, you had the composition of functions, and it was the derivative of the outside with the inside staying the same, but you had to remember to multiply times the derivative of the outside. The derivative of the inside. And so what is it with integration? It's if you integrate this part right here, then you have to get the original function, right? So again, differentiation, we went in one direction. Anti-differentiation, we're going in the other direction. So this is what it looks like right here. It says anti-differentiation of a composite function. Let g be a function whose range is an interval I, and let f be a function whose continuous on I. If g is differentiable on its domain and f is the antiderivative of lowercase f on I, then the integral of f of g of x, g prime of x dx equals f of g of x plus c. Look, all of this just makes it look a little crazy right here. Here's really what you want to look at, is this step right here. This is your key step. If you do use substitutions, what it's saying is the integral of f of u, notice it's with respect to u, equals capital F of u plus c. In other words, we're going to make our u substitutions. We're going to solve for dx. We're going to replace them in, do our integration, back substitute for u, and we'll get our answers. So let's see some examples of this on the next page. I know this theorem looks nice and confusing, but I think you'll pick it up pretty quickly on the next page.